Okay, here is warm-up 9.1.2. Okay, so going to need a scientific calculator on some of these problems, not on the first two actually, but the first three. But on this column, we will need a scientific calculator. So you need one that has sine, cosine, and tangent keys. Okay, so first problem. This kind of looks like it might be a 45, 45, 90, but I can't say for certain if it is because the angles aren't marked and the legs aren't marked as congruent. But that's okay because I can just use the Pythagorean theorem, right? The Pythagorean theorem says that a squared plus b squared equals c squared. C would be the hypotenuse, which is across from the right angle, so that's my C. So the other two sides are the A and B. It doesn't matter which one's A and which one's B. So you could have said 5 squared plus x squared, because that would be equivalent. But the 7 has to be in that C position, okay? Then I'll start simplifying this. So got 25 for 5 squared and 49 for 7 squared. Okay, subtracting 25 now. So this is going, x squared is going to equal 24. Okay, and now I want to take the square root of both sides. I'm only going to use the positive root because this can't be a negative value for the side of a triangle. All right, and then I still want to put this in simple radical form. So the way I like to do that is break apart, since it's not a perfect square, it's going to be a little less than 5, right? Because root 25 would be 5, so this would be something like 4.9 as a decimal. But simple radical form, I like to break it apart to look for twins. So I'm thinking, okay, 4 times 6 is 24. You could do 2 times 12 or whatever, okay? But I don't have any twins yet, so let's keep breaking that up. So 4 is 2 times 2, and then 6 is 2 times 3. And then I'm looking for twins, okay? And hey, I've got triplets for the 2's. Only looking for twins though, so these twins are going to make a jailbreak. One gets out, one doesn't. So I've got a 2 on the outside, and then the 2 and the 3 don't have a twin, so they're stuck in there. Just multiply them together. So 2 root 6 is simple radical form for that x value. Okay? Next problem. I can't use Pythagorean theorem here because I only know one of the 3 sides of the triangle. You could plug it into the Pythagorean theorem, but you'll have 2 variables. Okay, but I do have 45 degrees, 90 degrees, and since all 3 angles add up to 180, my missing angle then is going to have to be 45. Hey, this is a 45, 45, 90 triangle. So when these two angles are congruent, then the 2 legs are going to be congruent as well. So that means that y is 7. Okay? At this point, I could use Pythagorean theorem. I could square both of the legs, and that would equal, the sum of those would equal x squared. Nothing wrong with that, but there's also a relationship you can use where you can take a leg and multiply. It's going to be getting bigger, so that's how I remember I'm multiplying by the square root of 2. So x then would equal 7 root 2. And there we go. Okay? The next one, this one is going to be a 30, 60, 90. Again, I can't use Pythagorean theorem here right now. Don't have enough sides. But I've got this missing angle here. Now I can use a special right triangle relationship. Okay? So my hypotenuse is going to be up here, right? The x. The other 2 sides are legs. This is going to be my shorter leg. Not because it looks shorter, but because it's across from the 30-degree angle. That would be the smallest side. So this is going to be my, what I call the long leg, okay? Short leg, long leg, that's my abbreviation there, okay? I have the long leg. I usually like to get the short leg as quickly as I can. So I'm thinking, how can I get from long leg to short leg? Well, it's going to be getting smaller, so instead of multiplying, I'm going to be dividing. And then you just have to remember what to multiply or divide by. Here I'm going to divide by the square root of 3. So going backwards and forwards from short leg to long leg in a 30, 60, 90, you're going to be multiplying or dividing by the square root of 3, depending on which way you're going, okay? So here, let me do my work for y over here because I didn't leave much space. So it's going to be 10 divided by root 3. I'm going to write it like that, but then I still need to go simple radical form. I've got no twins in there, but I've got a square root in the denominator. So I'm going to clone the twin for my 3 like that. Do the same thing to the numerator. So now I've got 10 root 3 over, well, that would be root 9 actually, which is 3, but you can also think about it with the twins. One of those gets out. So this is going to be 10 root 3 over 3. Okay, so let me put that in the picture here. 10 root 3 over 3 is y. Okay? Okay, so now that I have the short leg, I can multiply to get the hypotenuse. It's going to be getting bigger again, so I'm multiplying. Here we're multiplying by 2. So I'm going to double 10 root 3 over 3. So that's going to be 20 root 3 over 3 when I double it. Sometimes I see people double 10 root 3 over 3 and get 20 root 3 over 6. Don't double the denominator because think about adding this to itself. The denominator, you'd have a common denominator of 3. That's what you're doing when you're doubling, okay? All right, there we go. Now the next 3 problems, these are not special right triangles. They're not 45, 45, 90s. They're not 30, 60, 90s. Also, I don't have 2 sides on any of these, so I can't use the Pythagorean theorem. So I'm going to have to use trigonometry. I'm going to use SOHCAHTOA. So SOHCAHTOA, just a little acronym to help you remember sine, cosine, and tangent. Sine, cosine, and tangent trig ratios. So you want to put yourself in these triangles at the, you never want to be at the right angle. You want to be at one of the acute angles. You want to be at the one that's marked with a number. So in this first problem, I want to think of myself down there. So there, hey, there's me. Next problem, I'm going to be down here at the 16 degrees. And the last one, I'll be up at the 48 degree angle. Okay? So now I'm going to set up a trig function. So looking at this, the parts I'm dealing with, well, the 10 is the hypotenuse. Okay? These other 2 sides are legs, but now I'm thinking of the legs not as short leg and long leg, but I'm thinking about which leg is closer to me. So this would be the adjacent leg because it's closer to me down there. This one's farther away. It's also across the triangle. It's opposite from me, so this is the opposite leg. Okay? So now I need to decide. I'm going to pick the right piece of SOHCAHTOA, sine, cosine, or tangent. I'm going to pick the one that uses an O and an H. That would be the sine part. Okay? So I'm going to write sine. I want to indicate where I am. I'm at the 63 degree angle. And then I'm going to do opposite over hypotenuse. So that the letters are in the right order. Opposite over hypotenuse is going to give me x over 10. Okay? Now I'm going to want to solve this for x. So I'll multiply both sides by 10. To isolate the x. So x is going to equal 10 times sine of 63 degrees. It's not going to be sine of 630. Sometimes I see people multiply the 63 by 10. Don't do that because sine of 63 is its own number. We're multiplying that number by 10. Okay? I'm going to have to put that in my calculator in a minute, but I'm going to set the rest of these up first, and then we'll use the calculator at the end. Okay? So this one, hey, that's the opposite leg there. That's unmarked. So this is called the adjacent leg. And then the x would be the hypotenuse. Okay, so I'm looking for the part of SOHCAHTOA that uses an A and an H. Well, that's the cosine part. So cosine of 16 degrees is going to equal, I want adjacent over hypotenuse because that's the order of the letters, so 13 over x. Okay, so if I want to clear the fraction here, it's not going to help me to multiply both sides by 13. Then I'll get 169 over x right here. I don't want to do that. Okay, so to clear the fraction, you could multiply both sides by x, then the x would be over here, and then you divide by the cosine of 16 degrees. And you can do it that way. But when you have the situation with a variable in the denominator, I made up a maneuver called the incredible switch. You can just switch those positions, so algebraically that's where you'll end up, and it just saves a little bit of time. So I made that up, I invented that, but you're welcome to use that for free, absolutely free, for the time being. Later on there might be a paid subscription or something. I'm trying to figure that out. Okay, anyways, so I've got that ready to input in my calculator. Let's set the last one up. This is the opposite leg, and this is the adjacent leg. The hypotenuse is unmarked, so opposite and adjacent. Hey, that's using the tangent part, right? Oh, I wrote tangent. TOA is what I meant. SOHCAHTOA. Sorry, writing and talking at the same time. SOHCAHTOA. Oops. Okay, so SOHCAHTOA, so opposite over adjacent. I'm at the 48 degree angle. Opposite is x, and adjacent is 12. Okay, then I'll multiply both sides by 12 to isolate the x. You could do incredible switch, but it's not going to do you any good here, right? I want to isolate the x, and I can just do that by multiplying by 12. Okay, so now I've got these ready to put into my calculator. So here comes the scientific calculator. Now you need to make sure you're in degree mode because these angles are all written in degrees. So I'm going to check the mode button on here, and I can see, okay, I'm in degrees, but if you got a different calculator, you might need to play around with it. But you can test if you get the same answers as I do. So I'm going to type in 10 sine 63 and hit enter like that. Some calculators you might need to find sine of 63 first and then multiply by 10. So just play around with your calculator. I'm going to round these to the nearest hundredth. So this is about 8.91. And it makes sense. It's a little bit less than the hypotenuse, right? Hypotenuse should be the largest side. Okay, this one, I'm going to type it in my calculator as is. But play around with your calculator. Some calculators, you might need to do the denominator first, and 13 divided by whatever that decimal is. So I got about 13.52. And that makes sense because, again, that would be a little bit larger than that leg of 13. Hypotenuse should be the largest side. Okay, and then 12 times the tangent of 48 degrees is about 13.33. Okay, that's the end of the warm-ups. Hopefully I don't get angry comments because I wrote TAN instead of TOA at the top. At least I caught it before the video was over. Okay, I hope you have a good day. That's the end of the warm-up, and I'll see you next time.